What if we told you that building a small nuclear power plant could be the key to a sustainable future? Or are you looking for a plan for a nuclear reactor that is both safe and affordable? With more than 80 styles, knowing where to start can take a lot of work. But one design, the GE Hitachi BWRX 300, is slowly pulling ahead of the rest. Although it hasn't gained much attention from the general public, GE's tiny design is winning projects left and right in countries, including the USA, Canada, and the UK. So why is the BWRX 300 so popular? It's a simple version of a famous design made by a renowned and trustworthy business at a fair price. Also, it's almost done and ready to be built, which is unusual for small nuclear plant designs. In this piece, we will look at why the BWRX 300 has become the most popular reactor in the world, from its humble beginnings as a smaller version of GE's bar to its focus on collaboration and partnerships. There are already more than 80 designs of small nuclear reactors on the market, from water-cooled reactors to molten salt reactors and beyond. Interest in the competition has expanded to the point that governments and utilities are spoiled for choice due to renewed efforts for a carbon-free energy and reliable electricity. However, the GE Hitachi BWRX 300 has quietly begun to set itself apart from the rest of the group. It's understandable if you've never heard of it. If you work in a field unrelated to nuclear energy, the industry needs to pay more attention to it. A lack of media attention and press coverage is offset by the fact that it's being constructed. The widespread appeal of the BWRX 300 can be attributed to its affordable, stripped-down version of a tried-and-true design by a manufacturer with a solid reputation. General Electric has been designing nuclear reactors using something other than radically new technology. In the past 12 months, several additional initiatives have announced plans to implement GE's compact design. Countries like Canada, the US, Sweden, the United Kingdom, Poland, and Estonia have all achieved considerable strides in BWRX 300. These changes range from a general preference for certain technologies to actual building. GE's huge head start is intriguing to dissect for its potential and limitations in the long run. So let's dive in and discover why the BWRX 300 went from a potential reactor to the most popular one today. GE's economy simplified boiling water reactor formed the basis for the BWRX 300, a more modern reactor that generates over 1500 MW of power. Despite this, GE scaled back the design and power output to 300 MWe, classifying the reactor as a small modular reactor. Similar to previous methods in this class, SMRs have the potential to attract more customers because of their lower initial investment and quicker construction time. The concept of a miniature replica of a colossal reactor is not unique to GE. SMRs based on Westinghouse's AP1000 reactor technology have been designed and secretly abandoned by the company. Babcock & Wilcox's empowered design and the Canadian CANDU SMR, which was developed by the considerably bigger CANDU 6 reactors. All of them relied on standard, uninspired concepts that fizzled out. However, GE's design has some advantages over these plants. To start, the design is virtually done. Small reactors on the list are primarily the only concepts at this point. While many companies boast that their idea would change the world or use up all nuclear waste, details matter in the atomic industry. GE's reactor design is supposedly shovel-ready, term that marketers and legislators use. The other Western design at a comparable stage is NuScale's Voyager SMR, which is currently submerged. Compared to newer corporations, GE has the credibility and trust of its long history. The BWRX 300 has also benefited from the efforts of many people working together. To get the product to market, GE has actively sought collaborations with other businesses, governments, and utilities. Canada's Ontario Power Generation, Poland's Polska Grupa Energetyczna, and Estonia's Fermi Energia are just a few of the companies with whom GE has signed agreements with to explore potential BWRX 300 reactor deployments. In addition, GE has been collaborating closely with the U.S. Department of Energy on the Advanced Reactor Demonstration Program, which is designed to hasten the introduction of cutting-edge nuclear technologies in the USA. GE said in March of 2021 that it had received $1.9 million from the initiative to facilitate the licensing of the BWRX 300 design. The BWRX 300 design has significantly benefited from all of these collaborations and partnerships, which have increased its profile and solidified its reputation. Small nuclear plants may become more popular as more countries and companies look for carbon-free energy sources. We don't know if the BWRX 300 will be the most popular design in this category, but it's a good candidate. Small nuclear reactors are becoming more appealing as a practical to get energy because of these reasons, even though there are problems to be solved, like worries about how the public and regulators will react. It's hard to ignore the possible benefits of SMRs. Small modular reactors, or SMRs, could be an important part of the future energy mix, as the world looks for ways to deal with the coming climate problem and the growing need for energy. If you are worried about how reliable our country's energy source will be in the future, you should keep an eye on how small nuclear reactors are doing. They have the key that will open the door to our future happiness and success together.